okay, of the wheel and reel. Okay. So this will be T. I'm going to call it TW or TW. Okay. So this is equal to half Ig omega squared. Okay. So half Ig is equal to 0.5625, and then you have your omega squared. Okay, so 0.5 times by 0.5625, 0.2813. Okay. Now we also realize, right, that the reel has a linear motion, is generating a linear motion, lifting up the what? Lifting up the crate, yes or no? Okay. So next, we are going to calculate TR. So kinetic energy to move the crate while the reel. Okay. So why I put while the reel? Because the reel, the weight is attached to the reel and not to the wheel. So this is our wheel. The smaller part where you can see the ropes are, this is the what? Wheel. So this is the one that is generating linear motion to lift the crate. So with this, I'm going to call it kinetic energy. So we're going to call this TR. So TR corresponds to half mv squared. Now the mass over here is due to the what? The crate. Repeat again. The m over there is due to the crate. The inertia, the mass moment of inertia is the energy required to rotate the what? The wheel. But also it's attached to a reel. The reel is attached to a crate, and that's lifting up a mass of 10 kilograms. So you have to be really, really careful down here, okay? So we know for this formula that we use, this is for what? Linear motion, right? For this case, this is due to what? Rotation. Okay. So from here, this will be equal to half. This will be just 100. Okay. Why we don't do 100 plus 25? The moment of inertia already consider the what? 25. Are we clear? Okay, you don't like 100 plus 25. You don't do that. And then you have v squared. I think I'm going to use small v squared. Okay. And I'm going to put here, note, the v over here is related to what? 0.1125 omega. Right? Yes. No, it's just the energy to rotate the wheel without the mass, because it is not generating rotation. The weight is just linear movement. That's why you call it. Loaded versus unloaded. The direction of the weight will change. Okay, it is going down, then the direction of the weight will change.
let's assume the crate wasn't attached, right? To generate the same torque, we would need to have a different omega versus the way it was attached.
Yeah.
So then,
For now, if it's going down, you're right, the velocity will change if the moment, applied moment is the same. Okay? That's why when things are flying down, can go quicker. For that reason. So for here, we know that V is equal to 0.1125. So I'm going to point this to here. Right? So this is a relationship that we could get. Multiplied by 0.1125 squared, omega squared. Okay. So 0.5 times 0.5 times 100 by 0.1125 squared is equal to 0.6328 omega squared. Okay. So these are all the kinetic energy, okay, at point 2. Okay. So at T2, when the crate is lifted up by 1.5 meters, okay, T2 will be equal to 0.2813 omega squared plus by 0.6328 omega squared. Okay, so we add this together with this. Okay, so 0.2813 plus by 0.6328 is equal to 0.9141 omega squared. Okay, so now we have finished calculating the energy. Kinetic energy. So coming back to this expression over here, the governing equation, we know what is what. For now, we know what is T2. Okay. So the next thing we are going to consider is what? The work done. Okay. We have to consider the work done. Okay. So next, we have to consider the work done. So now we are going to look into the work input work input by the motor. Okay, so we are going to look at the work input by the motor. Okay, so the motor is over here. So we know that is equal to 0 to theta, and this is d theta. Okay. So we know this expression over here, the moment of the motor, which is given to us, is 60 bracket 2 minus E minus 0.1 theta, and this is what? E theta. Okay. So when you integrate this expression over here, you get 60 on the outside, 2 theta, minus E minus 0.1 theta divided by minus 0.1, close bracket, and this will go from 0 to theta, and then you have an expression over here where 60 bracket 2 theta minus, so become plus, divided by 0.1 is equal to 10, E minus 0.1 theta, close bracket. Did I do my integration properly? You guys should be better. Okay, so this is again 0 to what? To theta. we need to find theta. Right? So the next thing we have to do, we have to determine our what? Our theta. Okay. So theta over here, what we are trying, the theta we are trying to determine is, I'm going to call this theta B. Okay, so over here, I'm going to draw bigger. Okay, bigger. If we look at our motor and our pulley, right? So this belongs to our motor. This is our wheel. Sorry, don't change the name. Okay. So what we want to find is, we want to find what? Theta B. Okay. And we also, theta B is affected by what? Theta W. Okay. Theta of the wheel. Okay. And this is affected by the distance moved by the crate. Okay. That's where now you can see there's a lot of components for this question. There's a lot of components for this question. But mathematically straightforward, right? You just need to what? Analyze. Okay, analysis is important over here. So we know the distance move, or distance dirt. Really, Eugene? Distance move by the weight or by the crate is equal to 1.5 meters, right? So not sorry, I think I got this wrong. Okay, so rotation of the reel, can you change this, please? Right. So why this is important? Because if I were to take the wheel, my radius will be wrong. So we know that this is radius of the wheel. This is radius of the what? Reel. If you have taken the one wrong, you might be in trouble. When I was solving this, I made that mistake. Okay. So rotation of the reel, which is equal to theta r. And theta r over here, sorry, theta subscript r multiplied by r is equal to 1.5. Okay. Why? Because we are taking the arc what? The arc distance. Right. The formula for the arc distance, where theta over here is in what? Radians. If theta is in degree, the formula change from theta over 360 multiplied by what? 2 pi r. Yes or no? So this is our what? Which is equal to our arc circumference. Okay. If theta is in radians, in case you forget, then it becomes theta over 2 pi multiplied by 2 pi r, which is equal to your arc circumference. So when you cancel, this ultimately become what? Theta r in radians, in case some of you forget. So therefore, theta r over here is 1.5 divided by the radius. Okay. And the radius we're going to use down here is radius of the what? Of the reel. Okay. So it's 1.5.